up to that. Thanks for having me here. Really appreciate it. It's cool to come to Munich. I've never been here, so that's pretty awesome. I'm Wouter de Bie. I'm a team lead for data infrastructure at Spotify. I do work in Stockholm, but I'm Dutch, so you cannot speak sort of secret German because I do understand. Who am I? Well, according I don't know if people have seen it in the news lately, but sorry Cloudera, we have switched from Cloudera to Hortonworks lately, and it was picked up by some media. According to Zedinet, I'm de Brie, so apparently I'm this. Yeah, copy-paste error somewhere from a press release. Anyway, so what I would like to talk about a bit today is like why do we have data at Spotify? Why is data important for us? And I'll go into a bit of details on how have we set up our data infrastructure over the years. But why data? Because we do play music, right? How many people do know what Spotify is? Or how many people do not know what Spotify is? Okay, one. We do music. We do online streaming. But why is data important for us? Spotify started in 2006, we launched in 2008, and back then we were the only company in the world that legally had licenses to stream music. That was great, we had a large catalog, lots of tracks, but nowadays, basically everybody can do the same thing that we do. If you have a bag of money and you have a bunch of developers, you can start streaming music. And that's basically because record labels understand that this is actually a viable business model. So that for us, we had that exclusivity. We don't have that any longer. There are other competitors. Google is doing Google Play. Apple start doing their radio stuff. We have smaller competitors. So for us, it's really important to sort of stay ahead in the game, and we do that by iterating quickly and by learning from things that we do, things that we have done, and things that we think are interesting in the future. And data helps us enormously with that. So we do a lot of analysis and things like that. I'll go into that. But it basically comes down to learning faster so we can move faster, we can iterate quicker on our product. So today I would like to present a bunch of use cases, or give you some context, talk a little bit about use cases, how do we use data, talk about our infrastructure, and sort of take what lessons learned over the years that we've built this out. So some context. As I mentioned, Spotify started in 2006. We launched in Sweden. It's a Swedish company. Nowadays we have offices all over the world. We've launched in 28 countries. We have a main office still in Stockholm, a large development office in New York, and for the rest is all small sales offices. We have 1,200 employees, plus of which 450 are engineers. 26 million active users on a monthly basis. We have 20 million plus tracks available. 4 data centers, so yeah, we're not as big as Google. We have 4 data centers, 2 in Europe and 2 in the US. And I work with 17 data engineers building a platform for data. So the idea is basically that it should be able, everybody working at Spotify should be able to access data in an easy way. And that comes with a lot of tooling, a lot of education and things like that. But I'll go into that a little later, like how that exactly works. So some use cases. We're a data-driven company. When Spotify started, I used to call that, the way that we worked was sort of gut-driven, like based on a gut feeling. We did things that we thought was right, or that our competitors did, or things that our competitors didn't do. But yeah, that proved to be sometimes not the right way. And since we have a lot of users, we have a lot of data, we can actually start using that. But when we started Spotify, we started with reporting. Reporting is very, very crucial for us because we have to report what is streamed, what is played to labels, other licensors. We have partners that work with us. So, for example, telco companies, they bundle Spotify with the mobile subscription, for example. They pay part of the Spotify subscription, so they also want to know how much is in use. And obviously, we also have an ad-supported version, or an ad product, and we need to report to advertisers. And reporting from the beginning was really, really important. So we started, basically all our data was focused towards reporting to labels, so that they, at the end of the month, could bill us. But at a given point, our CEO, he said like, well guys, if we have so much data, why don't we start making decisions based on that? As I said before, it was also gut driven, but then we started doing more and more business analytics. And that was about the time that I started at Spotify 2.5 years ago, and we started analyzing growth, user behavior, sign-up funnels. Spotify is currently available on mobile. We have a desktop client for Windows, Linux, and Mac, Android and iOS. There's a web player. There's different ways that people can actually sign up for the service. So we need to understand like what are the hurdles that people have, and when do they drop out of the process and things like that. How can we improve sign-up rates? We started analyzing company performance or key performance indicators like daily active users, monthly active users. There's one metric that we use that's called engagement factor, which is basically the amount of daily active users over monthly active users. And it gives a good idea of how many people are active today and how many of those people are also have been active over the last month. So how likely are they to come back? That's a very important figure for us. We do a lot of A/B testing. Anybody not familiar with A/B testing? Okay. So the idea is basically in our client we try out features for a very small set of users and see what the impact of that particular feature is. And it could be that it's a positive impact, could be a negative impact, or yeah, no impact at all. And then we decide based on the small test, do we extend that feature, or do we roll it out to others? And data is very important there, obviously, because without data we don't know. We've done some segmentation analysis, tried to segment our users, where do we focus on, what kind of features are important for our users. We've done an NPS, we do an NPS analysis constantly, this Net Promoter Score. Anybody who's familiar with that? Net Promoter Score is basically, you ask your users one question. Would you recommend this product to a friend? Yes or no? And you can get quite a lot out of that. And we do that in the client. We sometimes ask that question, and users just click a button, yes or no, and then we use that to improve the product. Obviously, we track ad performance as well. And I want to give a small example of like how business and analytics works at Spotify. What I've done here is created a small graph of listening behavior in Sweden, and this is some data that we've plotted by weekday. So here's Monday to Sunday, and we've divided by age groups and just see how is listening behavior. When do people actually use Spotify? And there's some interesting things that you can see here. I don't know, can you guys see it in the back? Right. So here you have the age group 0 to 17 that sort of start using Spotify a little later in the day. And this is the day. So those peaks are made mainly sort of at 4 o'clock in the afternoon to 6. But yeah, that's because kids go to school, or I hope so. So we started looking at this. There's also an interesting, like a small bump, and this might be hard to see there in the back, but there's an interesting small bump that you don't really see in other days between on Saturday to Sunday night at about 2 o'clock. Anybody can guess what that is? Yeah, it's after parties. So people come home, put on Spotify. But what we also noticed was that there's a similar pattern here on the night from Wednesday to Thursday. Can anybody guess what that is? It's also after parties. Yeah, there is this phenomenon in Sweden that is called Small Saturday, or Lillördag. So a lot of students go out on and it's really a thing, you know, people go like, yeah, it's Wednesday, let's go and drink. I've never studied in Sweden, so this is like second-hand information. But yeah, you really see here that actually people come home, and it's mostly the younger age groups that have that. So that's sort of interesting, and then we compared our listening behavior with Spain, which looks very different, actually. Color coding is different, my bad, but here you see, well, you don't see those sort of ramp-ups for younger age groups, so I hope that Spanish kids still go to school. But yeah, let's not confuse correlation with causality. But anyway, what is interesting is that during the day the pattern is also very. By the way, you see also they do have after parties, but no small Saturdays. But especially during the day, you see there's difference. So younger age groups tend to use Spotify quite a bit. However, older age groups, there's a big dip. Can anybody guess why that is? Siestas, and we do call that siesta effect at Spotify. So, another analysis that I wanted to share is this was in October last year, where all of a sudden we saw that graphs started declining, usage started declining quite drastically in the US. People were like, what's going on? You know, is there a bug? Is our data center down or whatever? And it wasn't like that. So we did an analysis and plotted some geographical data. And I hope you guys can see that this is sort of the outline of the US. This is actually quite clever. I think a colleague of mine who just put that data in Excel. So yeah, it's all coordinates, right? So you don't need very advanced systems that you need to buy to plot geographical data. Excel sometimes works. I thought it was pretty clever. We do this actually quite a bit. Why not? So but what you see here is that, so the red and the green, red is bad and the green is good. And you see here, like Atlanta, minus 28%, around Washington, D.C. area, 28%, and upwards on the East Coast as well. Which was when Hurricane Sandy hit and power was out, things like that. And you can really nicely track also the day after, where, is this visible in the back as well? So you actually see there is minus 85% in New York the day after, where Hurricane Sandy hit at that point. Fun, interesting. I don't know actually why there's green stuff, like why there's plus 30% more land inwards. Maybe people just go there and evacuate. I have no idea. But it's sort of interesting analysis. Yeah, you could argue like, okay, what's the business use of this? These are more sort of they speak more to the imagination, but this was an actual use case, like why are the numbers down? So we drilled down into data to figure that out. When it comes to the ads or the listening behavior, you can think like, okay, maybe it's a good idea that we push for kebab ads at the middle of the night. I don't know. So the next thing that we do is with our data is we use it for we track operational metrics. So we use big data and all the data that we have for root cause analysis when there's stuff broken, applications die, backend services go haywire, or our network simply doesn't perform. We do latency analysis. Spotify has always been we're pretty proud of how quick you start playing when you click a track. And that's something that we continuously monitor. So if something's off, then we really dive into what's going on. Maybe we've had a bad release, or maybe something's going on with part of the network, things like that. We also use a lot of this data to do operational capacity planning. And it could be more like how many servers do we need to buy in between now and 18 months, or how many people, how much staffing do we need, how much bandwidth do we need to add, things like that. And the last thing that we've started doing is product features. I don't know if you use Spotify, you've probably seen a bunch of those. We use data quite extensively for radio. We have top lists in the client where you can see, okay, these are the top tracks for last week in your region or in your country, or things like that. And we started doing much more recommendations. And these are one of those things that we think are harder to do when you don't have that much data. For say our competitors that might not have that much users. And what is interesting when we started doing recommendations, this was actually in our radio feature We just use data. We use collaborative filtering to basically match tracks with other tracks or match users with other users. And when we started doing radio, we bought from a third party, we had a sort of partnership, and we used their technology to match a particular track with another track. So our radio works, you pick a track or an artist or an album, you tell that radio, okay, build a radio station around this, and it will give you similar songs. So you don't have to curate your own playlist, you don't have to search, sort of what we call a laid-back experience. There are companies that really analyze the content of the audio file. We don't do that. So they look at tempo, they look at timbre, they look at a whole bunch of different properties of a piece of music and try to match that with others. We basically only look at user behavior and try to match that. And we rolled it out, we A/B tested those two implementations, our own implementation and the third party, and ours was apparently 30% better, so we went with that one, which is sort of interesting. So just throwing data at the problem can get you quite far. So, and the idea is that everybody at Spotify should be able to use data, and this is internally, obviously, like not all our users should use our data. So that's sort of the idea why we started building infrastructure around data. So why data infrastructure? How we develop at Spotify is that we have built what we call a matrix organization, where a lot of organizations are built, you have a back-end team, you have a front-end team, you might have a data team, you have a test team, and they all work together building multiple features. We've seen that because Spotify has grown really ridiculously, I think, over the last 2.5 years. When I started, we were 250 people, now we're over 1,200. And it caused, that kind of setup that we had caused a lot of dependencies between teams and people waiting for other teams, because prioritizations in teams are different than other teams. So what we said is, let's create a different organization where when a feature has to be developed, we just put all the competences that that feature requires to be built, we put together in one team. We call that team a squad. But the idea is that that squad should be able to do everything in that feature. So develop everything. So the view, it is basically what you look at as a user. Could be mobile, could be desktop, could be web. There's always a backend component where your view communicates with. But they also should be able to write what we call a data pipe. And data pipes are used for data that's sent back to a backend service. In the case of radio, there's a lot of computation every night, and then we push that back into backend services, but also data for analysis. And all those, basically 4 components, a team should be able to do. Problem is that it's, you can put people together in a team, but we don't want people to start reinventing the wheel. And that's why we really need solid infrastructure, so that it's easy for others to build on. And it's a bit similar to what Google does, is they have all that already figured out for themselves, and they sort of now give it to the masses. As we are not as big as Google, our masses are developers, basically. So we try to build infrastructure for others. So a little bit about our infrastructure. This is actually a real picture from us, where we do have our, as I said, we do have our own data centers, and our Hadoop cluster was consuming quite a lot of power, and we didn't have that power, so somebody was upgrading power sockets or whatever in the data center. So it's sort of funny. So some geeky numbers, like what do we have at Spotify? Currently we have about 1 terabyte of compressed data from our users every day that goes into our infrastructure. We have 40 gigabytes from other services, like we dump a lot of databases, state, all over our infrastructure. We dump that into Hadoop. From that data we generate about 61 terabytes a day. Part of that is temporary, so we just throw it away again, and some of the data we keep. We currently have a 328 node cluster. However, there are machines waiting. In total we have provisioned 690 nodes with about 11,000 cores, and we're basically waiting, because we're in the migration from Cloudera to Hortonworks, so we're waiting to provision the other ones as well. We don't need them at this point. And apparently this is the largest Hadoop cluster in Europe. So there are large Hadoop clusters in the US, Google, or yeah, you guys do not Hadoop by yourself, but Yahoo, Facebook, Twitter, they have larger clusters, but this is the largest commercially used one. In Europe there are governments that probably have larger things, but they probably, we do not know. That's, yeah, you guys might. But yeah, so that's I think that's kind of cool that Spotify is sort of the first company in Europe to be able to do this at this scale. Yeah, we run about 6,500 jobs a day. That totals up to 192 a month. Yeah, interesting stuff. And geeks love these numbers. So how does our infrastructure look like? It's actually pretty straightforward, I would say. So we have backend services logging data, which we put into HDFS. I have a bunch of slides on like how do we exactly do that. We have operational databases. We mainly use PostgreSQL and Cassandra that we dump into HDFS in different ways. Then we run MapReduce on top of that. We use Hive for mainly analysts or people that want to get quick access to data in an ad hoc way. They can write their SQL-like query and just run it on a cluster. We don't use Hive for ETL jobs, but what we do is mainly use either Python or Java or Pig to do ETL, and that is all scheduled through a scheduling system we call Luigi. We've open sourced that half a year ago or something. It's on our GitHub, and that takes care of all dependencies between jobs. With that data that is produced, we either put back into products, so radio, or we now have a discovery feed where we do lots of personal recommendations. We provide reporting towards labels, and I got a question in Berlin where I was last week about like reporting, what kind of system do you use there. It's basically, the reporting for us is basically just large XML or CSV files that we provide to record labels. It's not like nicely marked up PDFs and things like that. For ads, we do use ClickView a bit for reporting there. So that's used, and we populate a lot of analytical databases that are that get aggregates. So aggregates we compute in Hadoop, and then we put them in Postgres or in Cassandra, and on top of that we have dashboards, and we have other tools for analysts to query that. So the three pillars of our data infrastructure are basically Kafka for collection, Hadoop for processing, and then we have a bunch of databases for analytics and for visualization. So data collection. We want to collect everything. And I forgot to mention that, but when I talk about data, it's really the metadata about that users create. It's not the actual audio that we stream. For us, that's just a file that's in some system that we stream to the user. It could be in a CDN, it could be in a peer-to-peer network that our clients connect to, but it's really about log files, basically, or dumps from databases. So we have put Kafka in place, and Kafka is a high-volume pub subsystem. Was initially developed by LinkedIn. It's now a top-level Apache project, and we started a long time ago with our own store and forward service. If you look at Spotify, we have, I think, 230 backend systems that all provide a particular small piece. So one system takes care of you being able to log in, the other one stores your playlists, one uses that you can search our catalog, and there's 230 of those. And what we used to do is we had a bunch of servers just rsyncing data from those backend servers. They just log through syslog, and then we put that into HDFS. We upload it to HDFS. But that was it was hard to scale that, and it was quite slow. We had sort of a delay of about an hour, of about 2 or 3 hours when the message was produced until the message was actually put into HDFS. And we said we want something more scalable and better. We looked at Apache Flume, didn't fit our particular use case. So we started doing Kafka, which was pretty cool. Right now it's from old backend services, a lot of backend services we're still migrating, but a lot of backend services into HDFS, but we also want to use Kafka from backend to backend for large volumes of data. Next to this, we have another in-house protocol that we use for backend services talking to each other in real time, but that's not where Kafka is used for. It's like large batches of data that we might need to transfer. And it was almost a good fit. However, Kafka doesn't provide message acknowledgements. So as soon as the message is produced, we do not know if it actually has ended up in HDFS. That's at least not in 07, which is a stable version. 08 was supposed to come out in January, never happened, or hasn't happened yet. And 08 has acknowledgements, but it's not end-to-end. So you have a Kafka producer, you have a broker, you have a consumer, and then you have HDFS, and we really want to track the whole pipeline there. Because for us, it's important that we actually store the data in HDFS and that we do not lose too much, because one track streamed is sort of like a monetary transaction. We have to pay labels at the end of the month for each track that is played. That goes in large volumes, so we can lose a little bit, but not too much. Yeah, if a message out of say 1 million messages, 1 or 2 get lost, yeah, that doesn't add up. But for it's a little bit different than the banking system where you really want the money on your account, right? If you lose a transaction once in a while, that's not good. For us, not very good, but okay-ish. So what we did, we hacked a bit on Kafka to make sure that we get acknowledgement from end to end. So we have a backend service, they produce data, the backend service produces data to a Kafka broker, then we have a Kafka client writing to HDFS, and our backend service has what we call a Kafka producer, and the producer basically keeps track of which messages have been sent, and it basically requires that an acknowledgement will follow within the next few minutes. If it doesn't, then and the acknowledgement comes when the Kafka client writes it to HDFS. We send that back to the backend service also through Kafka. If that acknowledgement never arrives, the message will just be sent again, which might cause duplicates in HDFS, but MapReduce is pretty well designed to get rid of duplicates. So we run over data anyway, so we do that in sort of a cleanup step. Normally when you deploy Kafka, it comes with MapReduce jobs that connect to your Kafka broker, starts like consuming messages from a queue, but we have a constantly running consumer basically because of the acknowledgement. Next to that, Kafka will also put stuff in S3 for backups and on tape. We have some tape robots still around that do that. So when we talk about sort of data transfer, we also dump a lot of databases, I mentioned, because we don't only have log files, we have production database, we want to dump state. We use Scoop, which is also part of most of the Hadoop distributions nowadays, also an Apache project, and we dump from PostgreSQL. You basically run a MapReduce job on your Hadoop cluster, and in parallel, your mappers start drawing data from a database. It's actually pretty simple, but it works pretty well. From Cassandra is a bit of a different beast because it's hard to dump data from Cassandra, especially if you have large clusters. So we do run MapReduce jobs for and basically just do table scans and take a partition of a cluster of a table. For uploading data into Cassandra, we also open source something that's called HDFS2Cas, where it will build SS tables, that's internal sort of storage format for Cassandra, and it will stream SS tables to a Cassandra cluster. And it's much faster than either do bulk inserts or row by row inserts into Cassandra. And for large databases, we have some databases that are hundreds of gigabytes big, and we need to quite often dump them. What we do there is we look at the logs of that particular database, see which records have changed or have been added, have been deleted, and then just dump the deltas. Periodically we merge those deltas into a new sort of snapshot, sort of basic snapshot strategy. So what have we learned from stuff? Or where have we failed? Or where have we raged? When it comes to data transportation, we started with a store and forward system, and that didn't scale. So if you you just started your startup and you think like, I want to do big data, really look at, think ahead and think like, okay, this might one day explode. And put a good system in place there. Kafka has a lot of multiple components, so it's not the easiest system that there is. You have Zookeeper, you have a client, you have a broker, we have a producer, so we also have to maintain that. We have 4 different data centers. We don't own our own connections between those, so internet weather is one of the things that definitely hit us. So sometimes, yeah, stuff has to catch up when it comes. All our data is in London, our Hadoop cluster is in London. Things from the US have to be moved there. And with a lot of what we've run into with a lot of Java, large Java systems, garbage collection can be a pain. So you have to really tweak it and understand what it does, and you have to have people that really understand JVM and things like that. So then the second pillar is Hadoop. We do quite a bit with Hadoop. So first part is, I already touched a little bit on that. We open sourced our own scheduler, Luigi, and we started writing that because at the time there was nothing really suitable out there. As I wrote, unless you really like Uzi. Who uses Uzi here? Do you like the XML?
Yeah, I'm good with it now.
Okay.
You know we have you now. With you can just drag and drop Uzi workflows now.
Right.
It wasn't there when you started.
Exactly, and that was what we started doing. We had a very old system that was old before Uzi was even there, written in Python. But then it was like, oh, let's try out Uzi. Let's build some workflows, and then we ended up writing a Python DSL on top of Uzi. And it doesn't really make sense. I actually heard that some people at Cloudera now recommend Luigi. So yeah, who knows? But the community there starts to pick up, which is kind of cool. I know that Foursquare uses it, Bitly, and there's a bunch of other companies start using Luigi now. And it's basically a generic scheduler that has support for MapReduce. You can do Python MapReduce or Java or Pig and Hive at Scoop. But basically the idea is when you run MapReduce is really simple. The paradigm is really simple, but what you often have to do is run multiple jobs dependent on each other, and that's the problem that Luigi tries to solve, to figure out which jobs depend on which other jobs, because you can have a big DAG of jobs, and you don't want to start processing data that's not there, basically. So Luigi takes care of that. So I would really recommend to check it out. If you look at Spotify, we have a bunch of different languages that we actually use. Historically, Spotify is a very big Python house. A lot of backend services are still written in Python or are still around that have been written in Python. And when we first started doing Hadoop about 4 years ago, 4 or 5 years ago, the guys that started that were backend developers writing stuff in Python. So a lot of jobs are actually still written in Python, and we use MapReduce streaming for it. I personally am not a big fan, but yeah, legacy, even in a young company like this, is around. It's nice for fast development. We do have a lot of Spotify libraries available with a bunch of business logic that we can just plug in. But it's much slower than Java, and you don't have nice access to Hadoop APIs. You can't have access directly to the file system and things like that. Java, basically the opposite there. It's fast, you have access to the Hadoop API, but it's pretty much for both language, and we don't have a lot of Spotify libraries available unless we maintain two versions, a Python version and a Java version. We also use Pig a little bit. It's nice because it's very small scripts that you have to write, but you have to think differently when using Pig. And it's yet another language that other people have to use. If you have a bunch of data engineers that are really passionate about Hadoop and big data, then it's not a big deal. But if somebody just wants to quickly write a job, then they find that threshold sometimes a bit high. And also, no libraries available. And this goes basically for other languages, like there's Cascalog, there's cascading, scalding, crunch, scrunch. There's a whole bunch of things out there. But we're actually moving towards something else than Python and Java. There's an interesting talk that a colleague of mine did at the Stockholm Hadoop user group. Videos are online, check it out on the meetup page about different languages that are out there. There's some research on those. So that's something. We do use Hive a lot, as I said, so it's a SQL-like language. For non-programmers, it's easy. Analysts, they just have, hey, I know SQL, so I can also do Hive. But yeah, the cons is that there are some moving parts there. You have a meta store that you need to maintain, and we see that for ETL jobs, it's not the best thing. It's better to write that in other languages. So our journey when it comes to Hadoop, we started 4 years ago with a very small cluster somewhere in the basement at the office. That grew to 37 machines, but there was basically sort of scrap metal put together. And at that time we thought, like, okay, we really need to scale fast now, and we didn't want to buy, because we didn't know how fast we needed to scale when it comes to data. So we moved everything to Elastic MapReduce. We ran Elastic MapReduce for about a year and a half, which was great. You get sort of pay as you go. However, I think for us it turned out that EMR was pretty expensive after a year and a half. In the beginning it was okay, but I remember one of our managers coming out of the meeting room with the bill from Amazon. It's like, yeah, it's not going to hold up, because for that amount of money we can actually do something ourselves. Plus the fact that we have all our infrastructure in-house, so there's a lot of data transfer between our internal infrastructure and Amazon in that case. I know Netflix, who are of the same scale as Spotify, they run EMR, but they do everything on Amazon. So for them, it makes much more sense, because you keep it all in the Amazon, in the cloud. While for us, we have to transfer a lot of data, things like that. And it's a bit hard for what we've seen back then. Was a bit hard for developers to develop against. But if you're new with Hadoop, use Google's platform now. No, seriously, I was seriously impressed. I think it's, and I'm going to use that $2,000. But definitely, don't start buying your own hardware unless you really know where you want to go. So we do capacity planning every 6 months, and we have 327 nodes up and running today. The rest just sits there and waits until we actually switch them on. They're just waiting to be provisioned, but we are a bit careful with that, because we were sort of moving towards, we have to migrate to Hortonworks, their data platform. So, and also what we've learned is that we really need to put a data retention policy in place. If you have a large cluster like this, people think like, awesome, I can just dump data on there. In total we will have 28 petabytes of storage, and then they go like, great, just dump my stuff on there and don't care about it. And that will fill up your cluster quite quickly. So we've put a data retention policy. People will have to specify how long do they need to retain this data. And it's interesting, if you ask people, they actually, I only need this data for 30 days. While otherwise they simply don't think about it and don't care. So that was a big lesson learned there. Where have we failed when it comes to Hadoop, or raged again? Initially we thought like, we just need good developers, then things will solve itself. But at this scale we really came to the conclusion we need Hadoop experts. We need people that really understand what they're doing and how that system works, things like that. We have hired a bunch of pretty good people. One of my colleagues, he dreams about Hadoop, seriously. He has nightmares about it, he told me, kind of cute. But we really need Hadoop experts. In the beginning it was okay, developers who had a little bit of sort of a service reliability or sysadmin background they could manage, but now we really need to, because there's so many knobs to tweak. And we underestimate the complexity of Hadoop. It comes with like thousands of parameters, and they all have to be tuned to your workload. There's no silver bullet. It's like, set this setting here and set that setting there, and you're golden. No, you have to really look at your workload, and it varies from company to company. The nice thing with Hadoop is that it scales horizontally. So you throw hardware equals money at the problem, and you will scale. But Still, it's money and still it's a big cost. This cluster was pretty expensive to buy, so it really pays off to start optimizing at some point. It's something we learned. And when we talk about adoption, for people to actually start using our data infrastructure, we really figured that we need good tools. So if you're in the process of building a data infrastructure, I think it's good to start investing in either building or buying good tools for visualization, for analysis, and things like that. So lessons learned. Like Hadoop has brought us very far. We probably would have never been able to do this in like one relational database cheaply. There are large enterprise solutions, but they cost quite a lot of money, say Oracle or something. But Hadoop has given us a lot of flexibility for a reasonable price. You sometimes might hear that Hadoop runs on commodity hardware, but commodity hardware doesn't mean it's cheap. So you're not gonna run your Hadoop cluster on like old 486s that you still have in the basement, or your Pentium 1s or something. If you look at our specifications, we have servers with 16 cores, 64 gigabytes of RAM, and 48 terabytes of disk. They don't come cheap, so it's still no mainframe solution that you need to buy. You can still get away with Dell or HP or IBM, whatever your vendor is, but it's not cheap. Also, Hadoop is not a silver bullet. It will not solve all your problems. We really see it as a very important part of our data infrastructure, but it's not. It will not just like, I dump all my data that I currently have in my MySQL database and I dump it in Hadoop and all of a sudden my problems disappear. It's not like that. As I said before, it's complex. It needs a lot of love and care. As I said, you want to hire some people that really dream about Hadoop or have nightmares about it, things like that. And what we also learned is that you really need to extend Hadoop. Like there's a whole bunch of tools that are currently in the ecosystem, but we've seen that when using Hive, we write a lot of custom user-defined functions. Same goes for Pig. Well, we've done our own scheduler, so there's a lot of development around the ecosystem that makes Hadoop fit for our use case. So quickly, I don't know how much time. I'm out. 5 minutes. 5 minutes. Okay, I'm really quick. Sorry about that. So other thing, database and visualization. We use databases for aggregates, as I already said. We used Postgres, Cassandra. We've created some dashboards on top of that. We use Cassandra for columnar sets, and databases are mainly used for low latency access to data by systems or analysts. So very quick overview or like some screenshots. We've created a data warehouse where users can submit jobs that run either on Hive or on Postgres databases or other MySQL databases. So one interface for everything. So they basically write their SQL-ish kind of query and they get sent off. Nowadays there is UI that is shipped with Cloudera's distribution, for example, which does a similar thing. Yeah, we started building before UI was there, so we're a bit early. We have dashboards. This is actually something that we're probably going to open source in the next half year. Graphs of data that come from the Cassandra or from SQL databases. Used a lot by management and others. In this case, we actually monitor our own delivery of data sets because I cannot share any other critical data, and this is okay. So in this case, we measure how quick or did a data set is a data set processed within the time that we set for it, and then you get a score, and we track that. We also have Spotify Analytics, and this is for record labels. I photoshopped out some numbers, but this is normal listening pattern for. I'm a big Pearl Jam fan, so this is probably Pearl Jam. Can't really remember, but this is day by day. So this is Sundays are our lowest days, and Fridays are the highest. So we give tools to record labels to just go in there and search for artists and albums and tracks to see what's going on. This is what happens when Daft Punk releases an album. Here is Get Lucky, their latest single that was released, was picked up pretty well. Highly anticipated the release of the whole album, and that's what happened there. Millions of streams on the first day. This is what happens when an artist dies. So yeah, she was also forgotten quite quickly, apparently. Well, actually, after Whitney died, the level is still up, but yeah, 2 days of high streaming or a week maybe. So, lastly, this is what we currently have open sourced when it comes to big data. So Luigi, our scheduler, we have Snakebite, that's a pet project with myself. It's a Python client for HDFS that doesn't use any Java at all. So it's pure protobuf. Because I was annoyed by the fact that when you do Hadoop FSLS, then it takes forever to start up. And within Luigi, we do that quite a lot to check if particular datasets are available. So since Luigi is written in Python, I decided to write a Python client, and it's much, much faster. And then we have HDFS to Cassandra for creating SS tables and importing stuff into Cassandra. So any questions? I have 2 slides more after this, so don't start clapping. Any questions?
Yes, then user runs anything, is there data he has to finish?
Sorry?
Can a user kill your Hadoop cluster while running something stupid?
Yeah.
And they do that.
Well, yeah, they sometimes they do. If you look at, well, they don't kill the whole cluster, but they just take up an enormous amount of resources that that they shouldn't do. If you look at Hive, I don't know if, like how many people use Hive here, but with Hive you can partition your data, and the partition comes in the form of basically an additional column to your table. We have added a date-time field for that is our partition. But you have to specify in your where clause which partition you want. So I want where this date and this date and this date, or some date range or something. Well, we've seen some people just forget that, and then they run over all the data, and yeah, take up a lot of resources. But we alert on that, and then we just kill the job and inform the user, okay, this is probably not what you wanted. We also have enabled Hive strict mode, which makes life a bit easier as well.
Actually, I have 2 questions. What was the reason to go with Hortonworks, and can you migrate without downtime?
First, the reason was there were a bunch of reasons, but it came down to price. Plus, we looked very closely to roadmaps from Cloudera and Hortonworks. I know Cloudera spends a lot of effort in Impala, which is awesome technology, but we have invested quite a lot in Hive, and Hortonworks has what they call Stinger project, where they try to make Hive 100 times faster, and that is, yeah, a little bit more interesting for us right now at this time. Migrating without downtime, no. So we will have to down the whole cluster and then yeah, just install new packages and bring it up. But luckily HDFS is almost at the same version, so that's just an upgrade of HDFS. We've already run some tests there, and the other part is that HTTP2, which you're waiting for, which is going to be released in October, runs everything on Yarn. So we'll have to recompile our stuff and probably make some changes. But since we have already a beta from HTTP, we're able to test that.
Another question regarding real-time analytics. Now what I understood is you are going with the analytics on Cassandra, for example, if you would like to have something very fast, almost near real-time. Did you think about using, for some use cases, not all, some extension of Storm, for example?
Yeah, we actually do. We have a small Storm cluster. It's not like in production. It's more like a sort of a test that we run, or beta. We don't monitor it and things like that. But we do have a small Storm cluster running that draws data from Kafka, just consumes data from Kafka, and then people can write their own topologies to do stuff. Yeah.
Because in the future, what I expect is if this already known Lambda architecture will be pretty much more recognized, then everything should be somehow run through Hadoop. Also, this real-time features like more related to Storm.
Yeah, the interesting thing with, I think the Lambda architecture is really interesting. We have looked at, because once our CEO or some people in management are like, yeah, real-time analytics, that's the new thing. You have to jump on that bandwagon. We have to do something with it. Okay, let's do some Storm stuff. And then we actually tried to figure out like what's the real use case, and we haven't really figured that one out when it comes to analytics. For us, a lot is in batch, so A/B testing. You know, you need some data for it to be significantly or statistically significant. In other cases, you know, we don't need that particular real-time data right now, but yeah, maybe in the future. We haven't really figured out like on the analytical side how we can use it.
What say you are using recommendation engine, you are using some sort of perhaps some sort of sentiment analytics in the future. This could be somewhere related to
Yeah, we've been thinking about that to do more real-time recommendations. Yeah. Yep. Absolutely.
You talked about the importance of easy tools. So what tools do you offer? Tools from the Hadoop ecosystem, or?
I think for us a big game changer, and that was the first thing that I did when I started at Spotify, is because I started like first couple of months. Now I'm heading up a team, but I started as a developer, and the first thing that I did was make sure that we had Hive. We didn't have that. And that was a big game changer for us because a lot of people all of a sudden had access to that. Before it was all MapReduce, and we had a data team just writing MapReduce jobs, while now all of a sudden people had access to it. And then we built this data warehouse on top of it, so that people didn't have to SSH into a machine, and now they have a nice web interface. So those kind of tools, it's either tooling that already exists in the ecosystem or tools that we build ourselves, like the dashboards, for example. That's a very big thing as well.
So extending the ecosystem, not going outside of it.
Well, it depends. The dashboards are not something that comes with the Hadoop ecosystem, so that's what we build ourselves. We're also we're constantly looking at technology, so we did an evaluation of Platfora. I'm wearing a t-shirt here. That's accidental. But we did a proof of concept with them just to see, like, hey, what kind of tools. We don't always have to build things, we can also buy stuff.
Okay, thanks.
It was in the back.
I was wondering, you were talking about the production system, but before you release a new software feature, how do your developers, do they own their own 600 nodes?
It's a good question.
How do you test?
We're actually, like, we've recently started with setting up something like that. We have sort of an internal cloud where people, like, not right now, not today, but they should be able to fire up a small Hadoop cluster. It also should be able to work with local data that they have, be able to generate sort of test data and run with that. But right now we see that still a lot of people use our production Hadoop cluster because we only have one Hadoop cluster to test their jobs as well, which is not very resource efficient. So yeah, we're currently working really hard on being able to test things, not having to have either Hadoop or spinning up a small local clustering machine, or maybe in our private cloud, things like that. I guess that was it. Any questions? So yeah, just to reiterate lessons learned. For us, data is really critical for our business. And Hadoop and other cutting-edge technologies like Kafka, a lot of stuff is still in beta, but we just use it anyway. It works pretty well for us. We also hired a lot of technical analysts, so people that can actually code. So not only do their Excel thingy, work with their spreadsheets, or work with some OLAP tool or whatever, but we really want our analysts to be able to code as well, so that they can write their own ETL job and fit them to their needs. So I said there's no one size fits all. So if a vendor tells you this is going to replace everything for you, don't believe them, because it's simply not true. It's all different components that work together. And we do have this sort of like build it ourselves mindset. Spotify is a large group of hackers. So everybody's like, I can do this better than anybody else. But I think we're at the point now where we really start thinking about, sometimes we just need to buy. This is not our core business. So, last thing, shameless plug, if you want to join Spotify, then let me know, because we're desperately looking for good data people, mainly in Europe. Thank you.
check it? No one? So, blue jacket was left in the other office. So, okay, someone else. Okay, yes, thanks for having this nice meetup. So there's still some food and some drink.